Now let's sketch one period of a transformation of a cotan function. Again, we'll proceed in the exact same way that we've done beforehand. I'm going to identify that the parent is cotan. And so this cotan function in terms of f of x is, or in terms of f of t, is 1/4 f of 1/2 t plus pi over 4. And usually if I have to at this point, I'll go ahead and factor out anything multiplying the t, but that's already been done for us, so one less step. So now we'll go ahead and identify the midline and the upper and lower lines. While I didn't make this remark when I sketched this graph, you can clearly see that the midline and upper and lower lines are the same for cotan as they are for tangent. They're 0 and plus or minus 1 respectively. And so once I identify that this only has a vertical shrink by a factor of 1/4, I can find the mid, upper, and lower lines by taking my old mid, upper, and lower lines, that is mid, upper, and lower lines for the parent. The midline has 0, multiply that by 1/4, and you get the midline for my cotan function, 0. And then the upper and lower, those are 1 and minus 1 respectively. So I'll just take these both and multiply them by 1/4. And of course, if there is a shift, I would add that as well. So this is 1/4 and negative 1/4. I think I'll go ahead and create my axes at this point and draw in my mid, upper, and lower line. So here's my t, here's my y, and I think I'll make this 1/4 and this minus 1/4. And so I have my midline here, my upper line here, my lower line down here. Now let's identify the horizontal transformations and apply them to the asymptotes and get our important t coordinates. So we have a horizontal stretch by 2 and a left shift by pi over 4. So we'll take our two asymptotes. Let's take a look at our graph of our parent function. So our two asymptotes at t equals 0 and t equals pi, and we'll apply those transformations. Let's list them. Horizontal stretch by a factor of 2, and a horizontal shift, which was left by pi over 4. And so if we take our first t coordinate, which was 0, and we can apply these, so 0 times 2 minus pi over 4, that gives us negative pi over 4. And then we'll take our rightmost t coordinate, where the right asymptote is, at t equals pi. We'll apply our transformations. Pi times 2 minus pi over 4. And you can get a common denominator here, 4 over 4. 4 times 2 is 8. 8 minus 1, that's 7 pi over 4. So to get our third important t coordinate, we'll take the average of our first and fifth minus pi over 4 plus 7 pi over 4, all divided by 2. This top here would be 6 pi over 4, and 6 pi over 4 is the same as 3 pi over 2. So we have 3 pi over 2 divided by 2, which is 3 pi over 4. Then to get our second, we'll find what's halfway between the first and the third, so negative pi over 4. I believe that was the first, yep. Plus 3 pi over 4 divided by 2, so that's 2 pi over 4 in the numerator. 2 pi over the 4 is the same as pi over 2. Dividing by 2 gets us pi over 4. And then finally, this fourth coordinate is halfway between the third and the fifth. That's 3 pi over 4 plus 7 pi over 4 divided by 2. So that's 10 pi over 4 in the numerator. 10 pi over 4, that's the same as 5 pi over 2, divided by 2, and we have 5 pi over 4. And so I think I'll go ahead and make the scaling that this is pi over 4, and that would make this minus pi over 4, so that's going to be our leftmost asymptote. So let's draw that in. So this is minus pi over 4, and then our rightmost asymptote is at the fifth important point, that's our important t-coordinate, that's 7 pi over 4. 7 pi over 4 is 7 of these pi over 4s, so 1, 2, 3, 4, 5, 6, 7. So that's where our second asymptote will be. And let's draw that in. After that, we'll need our second coordinate to be pi over 4, which I've already marked. Our third is 3 pi over 4, and then 5 pi over 4. So there's 3 pi over 4, and then 5 pi over 4 is here. And you see I have I have 5 equally spaced points here, which is exactly what you should get every time here. Now I pasted our function so that we can remember if there's a vertical reflection that we need to take care of. There is not, so the behavior of this graph is going to follow the behavior of the original in the sense that it's going to start at the upper, then go to the middle, then go to the lower. If there was a vertical reflection, we'd start at the lower, go to the middle, then go to the upper, but there's not. And so we'll start at the upper. I think I'll do yellow here. So start at the upper, then go to the middle, then go to the lower. We'll draw in the shape of our Cotan curve here. And we will draw in the appropriate behavior at the asymptote. It doesn't look that great. Let's see if I can do better. That should be fine. Finally, we can go ahead and make some remarks about some common definitions here. So here the stretching factor is just like the stretching factor for tangent. It's whatever the vertical stretch or shrink is without any negative. So in this case, 1/4. The midline is equal to 0. The phase shift is equal to whatever the vertical shift is, which in this case is pi over 4 to the left, so we'll put negative pi over 4. And finally, the period, you can find one of two ways. You can take the fifth point and subtract the first, or you can do the period of the parent function and divide by what's here. So I'll do that. So the period of the parent divided by, in this case, it's going to be 1/2 because that's what's multiplying the t. And the period of the parent is pi. So this is pi divided by 1/2, or in other words, 2 pi. And of course, you could take the fifth and subtract the first important t value and get the same period that way as well.